In this session, we are going to look at the basics of object-oriented programming. There are two main approaches in software development, the structured approach and the object-oriented approach. So when it comes to structured approach, we consider that the system processes the data into information with the help of operations and control structures. When it comes to object-oriented approach, we look at the system as set of objects, communicate and collaborate to achieve its objectives. In structured development, we think in terms of control structures, whereas in object-oriented approach, we think in terms of objects and their interactions. Structured approach is a basic approach, whereas object-oriented approach is a supplementary to the structured approach. Structured approach is much simple, whereas the object-oriented approach is relatively complex. And when it comes to developing systems, structured approach is faster, especially when it comes to simple systems, whereas the object-oriented approach needs upfront modeling. One of the disadvantages of structured approach is it is less maintainable and reusable code, whereas the object-oriented approach results in much more maintainable, reusable, extensible code. So let's look at a few points related to object-oriented development. First of all, we have to accept the fact that object-oriented concepts are not trivial. So therefore, we need extra effort and seriousness to understand those concepts. And also it is very important to practice the theory so that we can better understand. The upfront modeling is a must when it comes to object-oriented development. And also the real productivity of object-oriented approach is evident when you are developing complex systems. So we can understand the object-oriented software development in three levels: the fundamental concepts, the core concepts, and the advanced concepts in object-oriented development. So what are the fundamentals? The concept called object or class, the concept called messaging, and the concept of association. So those are the fundamentals of object-oriented programming. So then we have the core concepts: the abstraction, encapsulation, inheritance, and polymorphism. So then there are some more advanced concepts related to object orientation: the open close principle, the inversion of control, and some design patterns. So when it comes to developing the commercial software, it's a complicated task. So that is where we need the engineering approach. So there we first understand the problem by analysis, then we come up with a solution for designing, then we develop and test it. And it's very important that we adapt the object-oriented approach in the very early stage of analysis and design development. So let's look at the basics of object-oriented development. So we have the concept called object and class, the concept called messaging, and the concept called association. So here the idea is we look at the system as set of objects, communicate and collaborate with each other by passing messages. And they can pass messages if they are associated objects. Let's first look at what is meant by object. In object-oriented software development, object is anything that we are interested, relevant to the system. Another name for anything is entity. Since object can be anything, we don't want to lose any of these objects when we are modeling. So therefore, let's try to categorize them. So there can be some living physical things like customer, student, a patient. So there can be non-living physical things like goods, a vehicle, or drugs. And finally, we have the conceptual things as objects: a payment, an order, an account. So we are interested in two things when it comes to objects: its attributes or properties and behaviors or services. So what are attributes? Attributes are either properties that we are interested about that object, like name of a student or states of the object. For example, if you take an order, maybe the order is in the new state, order is in the paid state, or order is in the dispatch state, and maybe the closed state. And secondly, we are interested in behaviors of the object. So behaviors are either functionalities or part of the process, or any activities that change the attributes of a particular object. So if a particular activity change the attributes of object, that is a candidate for a behavior. So let's take some examples, starting with a living physical object, say employee. So it all depends on which context we are using it. For example, these are some typical attributes for an employee. An employee number, date of birth, maybe designation, salary. And maybe we are interested in behaviors like appoint, promote, check in and check out if we are interested in the attendance, and maybe the termination of the employment. So let's take another example, a physical non-living thing like a car. Maybe we are interested in registration number, date of registration, the model, color, and as behaviors maybe the registration, the transfer, or maybe we want to condemn the vehicle. So let's look at a conceptual object, bank account. So what are the interested attributes? Maybe account number, the account type, the interest rate, and balance, and there can be some more. So what are the behaviors? So we may be interested in deposit, withdraw, and maybe add interest. If you are new to the object-oriented programming, there are some confusions up front. So we want to clarify those things. The first confusion is, should it be an attribute of the object or attribute of an associated object? For example, if you take account object, it is obvious that account number must be attribute. The account balance must be an attribute. Maybe the interest rate. But should we take the account holder name as attribute? If you take a debit card or bank passbook, you may have seen the account holder's name. So therefore it is, sometimes you may feel like account holder's name should be attribute because everywhere you see it. But in reality, account holder's name must be an attribute of the account holder class or account holder object. So if an attribute is part of a different object, we better model it as attribute of that object rather than you take it as attribute of the other object. So therefore, we must model the account holder's name as an attribute of account holder or the customer rather than attribute of account class. Another possible confusion is, should it be a behavior of object A or object B? So let's take an example again. Say customer can deposit money to his or her bank account. Now the question is, should it the deposit behavior of the customer object or should it be a behavior of the account object? So at first you may feel like the deposit is done by the customer, so therefore it must be a behavior of the customer. But when it comes to object-oriented development, we consider that deposit is a behavior of the account object or account class. So that is what the concept called encapsulation come into the picture that we are going to discuss in a subsequent session. So if a behavior change the state of an object, that behavior must be in that particular object. So when you deposit money, the balance of the account change. So therefore, the deposit must be a behavior of the account object. And the customer object is call in the deposit behavior, call in the withdraw behavior. It is not a behavior of the customer. So at first it is little bit confusing, but you need bit of thinking. Once you get familiar with it, you will find it really comfortable. Now we have discussed about the objects and the attributes and behaviors. Now we are moving to the related concept called class. Object and class are related concepts, but they are two different concepts as well. Object is anything that we are interested, whereas class represents or models set of similar objects. So in order to model all the account objects, we can have account class. And also a class can act like a blueprint or factory to create objects in the runtime. So those are the two important features of class. So let's take one by one. A class represents or models a set of similar objects. For example, if you have different car objects, the car class models all the car objects. The customer class represents all the customer objects. The account class represents all the account objects. The second point is a class can act as a blueprint or factory to create objects of that type. For example, a customer object can be built from the customer class. A car object can be built from the car class, whereas an account object can be built from account class. So there's a way to create objects from a class in object-oriented programming. All the object-oriented languages support that feature. Now let's see how to model a class. When it comes to object-oriented development, the modeling is very important because we have to do some serious designing, modeling before digging to the coding. So we use unified modeling language to model. In unified modeling language, a class is represented by a rectangle, a rectangular shape with class name, its attributes and behaviors. So let's try to model some of the objects or the classes that we discuss. So we can model the employee class as the name employee, the attributes and the behaviors. So usually we use a pair of brackets at the end of behaviors. So similarly, the car class and the account class. So the attributes that we identified are in the attribute section and the behaviors that we are interested in the behavior section. So the second fundamental concept in object orientation is messaging. What is messaging? An object calling a behavior of another object is called messaging in object orientation. So messaging facilitates an object to communicate and collaborate with another object. So let's take an example. Say a particular customer is doing a payment, online payment. Now let's see what kind of activities happens in the banking system. Customer object is messaging the payment object and the payment object is going to message to account objects. The account object related to the customer, and of course there will be notification, and then the account object related to the vendor because it has to be credited, and again a notification object will be called. So you can see that by passing messages the required functionality is fulfilled. So messaging is calling a behavior of another object or getting the service of another object. Can an object message any other object? The simple answer is no. If a class A is associated with the class B only, object of class A can message an object of class B. Otherwise, it is not allowed to send a message. So therefore, let's try to understand what is meant by an association in object orientation. So association is a relationship between two classes. And later we will discuss few more type of relationships like composition, aggregation, inheritance. An association relationship has a direction and also multiplicity. So the direction can be either unidirection or bidirection. If it is unidirection, for example, let's assume that foo class is associated with bar class but not other way. So that means the object of foo class can send a message to the object of bar class, but object of bar class cannot send a message to the object of foo class. If the association is bidirectional, now object of foo class can send a message to object of bar class. Object of B class can call the behavior of object of foo class or send the message to object of foo class. So that is what is meant by bidirectional association. In UML, unidirectional association is represented by the arrow, whereas if it is bidirectional, rather than showing two arrows, we just remove the arrow. And also there is a concept called multiplicity when it comes to association. So the multiplicity can be one-to-one association, one-to-many association, or it can be many-to-many association. So what is meant by one-to-one association? For example, let's assume that order object can associate it with one payment and one payment is associated with one order. So then we say that the association is one-to-one. So here why we are saying 0 or 1 is maybe initially the order is not associated with the payment and later only it will be associated with payment. So that is why we just call it 0 or 1. We will be digging into those details later. So then there can be one-to-many associations. Maybe one, say, internet connection is associated with many bills. Assume that you get bill each month. And one bill is associated with one connection because assume that a bill is per connection. So then we say that it is one-to-many association. And again the 0 is maybe initially the connection is not associated with any bill. And the third category is many-to-many associations. So this is interesting. And there are two cases. In the first case, we just model it as many-to-many. Let's take an example. One user may like many posts and one post may be liked by many users. And if you are not interested in any other details about that like, so we can model it like this. Just the two classes and we just represent it as many-to-many. But if you are interested in additional information about that relation, association, the many-to-many association, so then we introduce a connecting class as well. We call it the associative class. For example, let's assume that a student can enroll to many courses and courses may have many students. And in this case, if you are interested in any additional things like maybe the date of registration, the amount paid for that particular course by a student, then we have to introduce the associative class as well. And we will be discussing how to convert this model into code in the next session. So in summary, in this particular session, we discussed about the basic difference between structured programming and object-oriented, the basic concepts of object-oriented programming, the concept called object, the concept called class, messaging, and finally we discuss the concept called association. And in our next session, we are going to do some coding to understand the basics of what is a class, how to create object, what is mean by sending message, what is association relationships, how we are going to code associations, the direction and the multiplicity, and that will be a really interesting session as well. If you feel like this session is useful to you, make sure you like it. And also if you have not subscribed, make sure you subscribe so that the future sessions will be notified to you. Thank you.